In this video, I'm going to show you the WinSchedule controls and components and some code that you can use to kind of understand the technique to bind to your records so that you can update, modify, delete, and create new appointment records as well as owners of these appointments. And this is just going to show you some of the code that is required to bind your objects to the controls themselves. This sample application is designed to show you some various interactions that can be achieved through the APIs of the WinSchedule components, as well as data binding techniques that you can use to hook this up to your objects that represent appointments and owners. So this particular application has some functionality that's been included. So for example, we can show the various owners that are loaded into this element. So this is just a list, and there's code written to iterate through and fetch all of the owners within the database backend and shown in this list. And by the way, by checking these checked items, by putting a check in it, we're showing that corresponding owner within the various views. So this is the day view, we see all three owners. Same thing with the week view, month view, and timeline view. So another thing that was added to this application's functionality was a context menu to set some other properties related to the owner. So if I just right click anywhere, I can modify the owner, and this brings up a user interface, which is essentially a form, Windows form, that has some properties. So right now, one of the things you may want to do is uncheck the locked property, which essentially, by doing that, what happens is it allows that appointment that belongs to that owner to be modified. So because it's unlocked, I can now just double click on any one of these time slots in any one of these views, and by doing so it creates essentially a new appointment, which is done so by this dialog. This dialog is actually part of the WinSchedule control set. So just create a brand new appointment, and then we could set some properties such as an all-day event, or it's only from a certain time. So let's say if it's from 1 to 2, and we could put a description in there. There's actions. We could execute. We could run an executable with some parameters, which pretty much gets sent to the shell for invocation. So we have that, and then we have a reminder capability as well. So there's quite a bit of things, such as recurrence. You could set a recurrence to occur daily, weekly, monthly, yearly, and any one of these days that you want to set up, or more details here with the various recurrence rules and so forth. So anything that you would expect from an Outlook-like resource scheduling application is at your availability here. So if I just create another appointment and save it, it's now added. So now I could resize the appointment, which actually changes the length or duration of the appointment. I can move it around, and that will change the start and end time accordingly. So everything that I'm doing to the user interface is actually changing the values of the backing appointment object. And then I could update the appointments table through this menu item. This actually is calling the appropriate methods on the DataSet to update the tables in the back end, because it's hooked up to a Microsoft Access file. And then this data is shared through the WinSchedule info component throughout all of these WinSchedule controls. So you can see what it looks like in the timeline view, the month view. Now I just changed it, week view. So let's take a look at Visual Studio to see how this is built, and take a look at some of the functionality that I wanted to talk about earlier. So I'm going to stop the application, and one of the things we could do is let's take a look at the database schema to make all of this happen. So this is a simple example. So we have essentially two entities within our Microsoft Access database file. Let's look at the appointments entity. So we have an appointment ID, which is an auto number that's essentially used to give it a unique value, like a primary key that is needed in this entity. Then we have an all properties member. All properties exist on the appointments as well as the owners entity, which is the other entity. So it's appointments and owners. The all properties member essentially is, think of it as a binary field type. So WinSchedule essentially can serialize each of its appointment owners, tasks, and any other types of data objects that it stores. It serializes them and it can store them in a database field, and that's what the property is representing. It represents an entire serialized instance of an appointment or an entire serialized instance of an owner. So in theory, you're able to essentially just have this one property as well as maybe the primary key to serialize the entire object within your database on record level. The only thing is that if you wanted to perform additional external queries outside of WinSchedule, you're not going to be able to query against all your properties stored as a binary field. So for example, if you wanted to run queries and reports based on appointments and metrics based on these other fields that each represent an important part of an appointment or an important part of an owner, you're not going to be able to do so from external queries. The only thing you'll be able to do with, if you use only the all properties member, is work with it within the context of WinSchedule. So these are the two entities that are available. So one of the most important things that we want to do here to set all of this up is set the data bindings. So let's take a look at the code required to enable the data binding support for the various entities that I showed you. So there's an important component that ties everything together. The tool in your Visual Studio toolbox is called the Ultra Calendar Info component. You may also know it as the Win Calendar Info component if you think of the marketing name for it that Infogistics uses. So in order to get started with this, what we want to do is get access to the data binding for owners property, and here we're just caching that as a variable within this method, and then we're setting the all properties member equals to this field name. Now these lines of code here, what we're doing essentially is mapping the property that the Ultra Calendar Info component expects to the field that represents the property in my underlying object model. So in this particular case, the sample developer happens to name the properties of the underlying object model the same exact as whatever the Ultra Calendar Info 1 would like to have, or similar at least. So the name member maps to name, the key member maps to owner key, the visible member is visible. So each one of these represents a functionality or data item from the appointment or for the owner. For example, the visible member dictates whether or not the member is visible within the visual controls. So if you remember, we kind of enabled that functionality for the end user through checkbox next to each owner's name. If I uncheck the checkbox, visible member turns to false, therefore the specific member whose property is set to false does not show up on the UI. And then the rest of this is just typical data binding syntax in order to set the data binding for the actual collection of objects, or in this case is a data set with a specific data table that is being bound to the calendar info component. And then we do the same exact thing for the appointments entity. We grab the Ultra Calendar Info's data bindings for appointments property, and then we're mapping the Ultra Calendar Info component's individual property requirements to the properties that are found on the underlying data model that we're binding to. In this case, it's a data table for the appointments, and these are all the column names. And that's pretty much what is required to set data bindings. So anytime you see a data binding for something property within the Ultra Calendar Info component, you do the same exact thing that you see here to map the properties that are required together with the properties that are currently existing in your underlying data model. And the same technique could be used for SQL Server or any other back-end database system that you have. Thanks for watching.
Infragistics. On the web at infragistics.com.